Thanks for inviting me to this webinar. Yeah, it's kind of a happy accident the way we started to plan for this webinar. During the holidays here in Europe, I obviously, since I don't have a social life, I was creating another graph in Neo4j, and I was looking for topics, and I was working on this data set about the Olympics, and that's what we'll be talking about today. It's a good example of how you work with Neo4j and how you work with graph databases. So that's what we'll do. We'll mostly talk about that data set, but first of all, if you're ever looking for stuff to read or do, then please feel free to visit any of these pages, my personal blog, our Graphistania podcast, the book that I wrote about Neo4j, or Twitter account, whatever you want to visit to keep yourself from roaming the streets. And please give me feedback. Give me feedback on any of these things, and that would be very, very good. So today we'll talk a little bit about Neo4j and Olympic graph in Neo4j. Why? Well, it's pretty simple. I've been working for Neo4j for 4 years now, and it always and continues to amaze me how graphs can yield new and interesting insights on any type of data set. And I've been in love with graphs and with Neo4j for ever since. I've done a lot of those types of activities over the past couple of years, and if you ever want to visit my blog, you'll find a lot of those. But essentially, it always comes back to the modeling power of graph databases, right? It's so nice to have a graph model to represent data. It's so much easier to understand, easier to work with, easier to reason about, and that's why people like myself, who I'm not a programmer, can actually do useful things with graphs. And then secondly, of course, because of the nature of the graph database and the way it works with index-free adjacency, with graph locality and graph local querying, it gives you the possibility to have an unbelievable performance for really complex queries or requests. So for that reason, I've been spending a lot of time explaining to people why the property graph model, which we'll be using today as well, is so interesting, right? The property graph model is so much easier to understand and so much more whiteboard friendly than anything that we've seen in the past couple of decades in the IT industry. And it's a very, very nice way to represent complex connected data sets, a hi-fi representation of reality, and that's what we'll be using today as well on the Olympic data sets. You'll see, some of these queries are fairly complex, not just to express them in a query language, but also to execute in any kind of data set, in any kind of database. Why? Because they involve a lot of joins. They involve a lot of connections, relationships between different types of data elements. And graph databases provide a great solution to that and a performant solution to that, because the relationship in the graph data model is actually the equivalent of a pre-calculated, explicitly stored join operation. It makes it really, really easy to find the next thing in the graph, to hop along the network and find those connected data points, and it's very, very powerful, right? So over the years, I've had many different examples that I've been working on, mostly because I don't have a social life, right? But it's for you to explore and for you to experience, I would say, and this Olympic graph is just yet another example of that, I would say. And so we'll explore that in today's webinar. And essentially, we're going to go through 4 different parts, 4 different types of exercise. The first part is, having a data set. Where does that data set come from? How do you work with it? How do you prepare it, so to speak? This is something that has nothing to do with graph database, but it's necessary. without data, no database. Then we model it into a graph model, then we import it into the Neo4j graph database, and then of course, hopefully we'll be able to do some useful queries with it. On my blog, the 3 blog posts about the Olympics are all grouped together with a label, right? So if you go and to that URL over here, you'll see we have the 3 different blog posts that explain these 4 different parts of the process for you, right? So that's what we will be going through. So first of all, what do we start out with? Well, we start out with a data set, right? That data set, in my case, I spent a little bit of time looking around for it, and I have to remember, right? I'm not a programmer, so I'm not in a position to go scraping data sets or compiling things myself or whatever. I just need something cookie cutter that I can start working with. And luckily, I found this particular data set here, which is hosted by The Guardian, the English newspaper, that when the Olympics were taking place in London, gathered a lot of the data into a Google spreadsheet. Right, so you can actually access that. But this is actually the medalist data for 1896 to 2008, right? Because they were preparing it for the 2012 Olympics. So this is not really what I was looking for, but still, it's good enough as a start, right? Because I also found the 2012 data also on the Guardian website. Right, I found the 2012 data in another spreadsheet, right? Obviously, like with all of these exercises, all of these, data manipulation, data import exercises, you'll find that, the data is not in the right shape. It's not in the right format, right? So as you can see here, the names of the athletes were in a different format. Some of the countries were actually called differently. The medals were structured differently. The events were structured differently. Even the sports taxonomies were structured differently. So I basically had to go through a couple of hoops in order to align that earlier data set from 1896 to 2008 to add the 2012 data, which I did. I've become quite proficient in Google spreadsheets these days. And there's some really cool tools that you can use to actually speed up this process. So I created a spreadsheet for 1896 to 2012, and it mentions the 2 Guardian sources, and it's essentially 4 sheets, right? One with the country codes, right? The IOC actually has a Olympic country code, which is 3 letters, whereas the ISO, the Standards Organization, actually uses a different country code, but hey, there you have it. The cities, right? So the different cities where Olympic games were organized obviously are located in a country, so I needed to sort of map that together as well. I had a sports taxonomy, right? So in the Olympics, they always talk about sports, disciplines, and events, right? So I had to kind of create a taxonomy of sports and disciplines in order for all of my data to be categorized correctly. And then finally, I have the medalist data, right? So all the medalists of the past 120 years are in this data set. Not 120 years, I'm sorry, 196 years, because it's only until 2012. Right, so you'll see if you visit this, there's about 30,000, it's still loading, that's why it's so slow, sorry. There's about 30,000 medals that were handed out, 30,317 medals that were handed out. And you can just browse that in the spreadsheet, but obviously the purpose of this exercise is going to be that, I'd love to get that data into Neo4j. Now, in order to import it into Neo4j, there's lots of different ways to do it, but sort of like the standard and maybe even preferred way of doing this is by using comma-separated files. And this is also why Google spreadsheets are so wonderful, because any Google spreadsheet that you have out there, you can just download it. You can download the live version of that spreadsheet as a CSV file, right? So any of the sheets in that workbook that you're working on, you just go to download file, download as, and then say CSV, and you will find that there's a CSV version of that spreadsheet available, which is great, really, really handy. And as I said, as you update the spreadsheet, it automatically updates the CSV file, which is really great. Right, so you can actually do a lot with that. And I end up with these 4 CSV files, one for the countries, one for the hosting cities, one for the taxonomy. I call it a sports taxonomy. It's obviously a very, very limited one. And then the actual data of each and every one of the 30,000 medalists. Right, so that's basically what I did. Right, I prepared the data. Right, I found the data set. I prepared the data set. I got it into a state where I thought I could work with it, which are these 4 CSV files. So then the next step for me was, how do I graph this? How do I get this into an Neo4j graph database? Because tables, schmables, right? We don't want to be just importing the table structure of those 4 CSV files. We'd like to do a little bit more graphy querying and exploration with it, which is why I had to create a graph model. Now, graph modeling, there's entire books being written about this. There's always, like in any modeling exercise, there's always going to be an interesting question, an interesting exercise to be done to decide, what data goes where, what data goes into a node, what data goes into a relationship, what data goes into a property, what data goes into a label. You'll have to sort of work the data set that you have into a model that you think is going to be meaningful for the exercise that you want to be doing. And guess what? This is not an exact science. It really depends on the types of questions that you want to be asking of the data, right? If I want to ask one kind of question, I'll make a certain modeling decision. If I want to make other types of questions or queries, I'll make a different modeling decision. And this is the way it works. And sometimes you'll have to iterate over this, and sometimes you'll have to maybe even have more than one model in the same graph database, right? Which is totally possible, right? So this is the type of stuff that happens, and which I would never claim to have mastered fully, but this is what I landed at, what the model that I created, right? And what you see here, let's start with the top right here. Those are the years or the games, right? The Olympic Games, right? Since 1896 until 2012, right? Those are the games that will be held, right? They are held in a city, right? And the city is located in a country. Right, so that's easy, right? That's pretty easy, right? Then at the top here, every game, right, will have a number of events, right? Those events are categorized into disciplines, which are parts of sports, right? So the sport discipline, that's basically a hierarchy, right? That's the taxonomy that I was talking about earlier, and every discipline will have multiple events, right? At the bottom here, we have athletes, right, which represent countries, right? And those athletes have a certain gender, male or female, right? And here's the meat, right? The interesting part, and probably also the part where I could have made a zillion different decisions. This is where I link the events to the athletes through the medals, right? And I went through a couple of iterations for this. I wasn't really 100% sure how to do this best, but I ended up saying, well, a medal is always going to be associated with an event, and there's always going to be 3 medals, right? Obviously, in a team event, there's going to be, X number of medals of each color, depending on the size of the team. But the medal is the reward for an event, right? And the athlete is connected to the event through the medal, right? The athlete wins a medal, which is a reward for an event, right? So that's the way this thing flows, right? I could have actually had athletes participating in events, right? So I have a direct connection through from the athlete to the event, but I didn't do that. Why? Because my data set is a medalist data set, right? There are no athletes that didn't get a medal, right? So it didn't make sense for me to do that. If I would have the full participants lists of all the events of all Olympics, then I would have made a different decision probably, right? Or a mix of those decisions. But right now it makes sense, in my opinion at least, to have a model like this, right? So on the right-hand side, the years, cities, and countries. On the bottom, the athletes of a gender representing countries. At the top, you have at every Olympic game in every year, you have events of a discipline in a sport, and then there at the center of this little model, you have the different medals, right? Right. So then I went through a data loading step, right? And if there's one thing that I've learned over the past 4 years, then it's probably that data loading into a graph is always underestimated, right? It's not that it's completely difficult. I would say that you get quite handy at it after a while, but it's something that you have to think through. It's never going to be like a push button operation, in my opinion, at least. So we were trying to make it easier and easier, but it's going to be an exercise where you have to think about, what are the different things that I want to be importing? How does the data set map to the model? And what are the steps that I'm going to be taking to load the data from the data set into the graph database? And what I found is that I try to actually take baby steps. I try to take it one step at a time. I try to really gradually build the graph from scratch by iterating multiple times over the different CSV files and loading the data from there. So there's going to be a lot of different steps involved, and actually what we'll do now is actually go into that, right? So here you've got your Neo4j, your naked Neo4j server, right? There's nothing in here yet, right? I'm actually working on, it's not finished yet. I'm sorry, Corey, I should have prepared better. But I'm working on a guide, right? This is what we call a Neo4j guide here, where you can actually, automate all of this, really, really easily, right, with all the queries and everything. But unfortunately, I wasn't able to finish it in time for this exercise. So as a result, I'm also going to show you my import script here, which I'm hoping is fairly readable as well. So first things first, what I'm going to do is I'm going to create the schema here for the data import, right? If you're not fully familiar with this yet, this is the step where you basically tell the database something about the data that you're going to be loading so that it can prepare for it and do it more efficiently, right? So indexes and constraints are obviously going to help you if you want to import the data very quickly. Now, you can just paste every one of these statements yourself into the Neo4j browser if you wanted to, but I tend to work with the Neo4j shell quite often. Why? Because it just allows me to dump these statements in here, yep, boom, and all of my schema operations have been executed, right? I can do the same thing in the Neo4j browser here. If I do schema here, it will give me the same thing. But the Neo4j browser doesn't allow me to execute multiple statements in one go, so I have to basically do that in a couple of iterations there, which is a little bit more time consuming. So here I've got some of the other queries, right? So here, this is just a simple one that is going to help me set up the genders, right? Here I'm going to be loading the countries, right? And look, the structure of this thing is always the same, right? I'm going to you have a load CSV statement, right? Which is going to take this CSV file, which is generated live from my Google spreadsheet, right? So as you can see, here it is. This is my my CSV file, right? This is what I end up with, right? So it's going to take that CSV file and it's going to do something with it. In this case, it's going to create the countries, right? It's going to create a node called C, which has a country label, which has a name property, and an OC code and an ISO code, right? So if I just take this thing here, and then I can go to the browser, or I can go to my Neo4j shell, right? And then I execute that, and it's going to say, yay, I've added something here, right? So now we've got something appearing here. We've got the countries appearing here already, right? So I'm going to do the same thing with all of these statements, and you'll find these statements, all of these, nicely prepared for you on a GitHub gist. So I'm just going to copy these. The lower ones, we don't really need those. So I'm just going to take all of this, and it's going to take a couple of seconds to go through all of these import statements. Very boring. It takes about 50 seconds to do the import. But again, you know, what I want to make sure you understand is there's quite a few things that I'm doing here in different runs, right? So I'm loading the cities here, I'm loading the taxonomy there, I'm loading the games there, I'm loading the events at the games there, then I'm starting to load the medalists, first connecting them to their genders, then I'm going to be adding them to their country representations, and then I'm going to be connecting them to their medals and all of that stuff, right? So there's quite a bit going on here, and it's all going on basically in baby steps, right? So one thing after the other, one thing after the other, right? So that's how it's working. Now, every import has its challenges, and I must say that in this particular case, I've hit a very interesting challenge, which I think is worth highlighting. And you know, there's no point in us trying to sort of hide it. Why? Because what we found out is when I was trying to connect the athletes to the countries, right? So when you look at the query here, it was this one over here, right? This one over here. When I was trying to connect the athletes to their countries, right? Athlete represents country, right? What happened was the query was just unbelievably slow, right? That, you know, there's about 30,000 athletes, there's about 200 countries, you know, it shouldn't be taking that long, right? So, but it did take, you know, a long time. It took over 300 seconds to do this loading, which is completely abnormal. And then I started to dig into it, and I found that there's actually an issue, or there was an issue in Neo4j, which was related to Cypher, right? As you know, Cypher, I mean, it's a wonderful query language. It's a wonderful query language in so many respects, but it's a declarative query language, right? It means that you actually need to do, or Neo4j needs to do quite a bit of work to understand what you, in your declaration, want it to do. Right? You declare that you want to do something, but in order to understand what actually needs to happen at the database level, there's quite a bit that needs to get done. One of the most important steps there is what we call a query planning step, right? Where, you know, your Cypher statement gets interpreted and gets converted into something executable in the database. Right. Now, Cypher is a declarative language, but for the longest time, and I've written this up in quite some detail on my blog post, it was using a rule-based planner, right? A rule-based planner is essentially a set of rules which would interpret your Cypher statement and then do something with it based on a set of rules, right? And this has worked fine, you know, for the longest time, but obviously those rules don't know anything about your data set, and so therefore they can sometimes come up with, you know, less efficient query plans, which is why what we've done over the past 2 years in Neo4j is we've transitioned to a cost-based planning system. A cost-based planning system uses the heuristics that the database knows about the data and creates a query plan that is completely adapted to your data set. That's really cool. Cost-based query planning versus rule-based query planning. Guess what? In this Olympic graph import exercise, I found that the cost-based planner came up with a much more complicated plan than the rule-based planner, right? They both came up with the same, operation, the same insert into the database, but that one took way longer than this one. And you can just see, from the structure of the work that needs to get done, why that is, right? The first plan, the cost-based plan, was so much more complicated than the rule-based plan. Luckily, Neo4j has this wonderful way of doing things, which allows you to switch planners, right? And this is something that I've used extensively in this exercise. You just prefix your loading queries, right? And I'm sorry, there's a little typo in here, which I can very quickly adjust, right? That there should be a space there. Right, there's just a prefix that you add. Cipher planner is rule instead of the default, which is cipher planner is cost, where you prefix that for the query and you get a much easier query plan. So I had to do that, and essentially that allowed me to load the data set really efficiently, which hopefully should have finished by now. Yeah, I think it has. Right, so if I go here and I say match n return count n, right, and it says 56,861 rows, which I think is essentially what I used to have in this loading a screenshot here as well. Right, so it worked. Now I can start exploring that in the Neo4j browser. Let's see here, how do I go there? I go there like this. The Neo4j browser will allow me to run a couple of queries here. Like, for example, I can start exploring the athletes, right? And I start clicking around and I find that there's the United States and the men of the United States and the gold medalists of a certain event. I'm sorry, why this should not have that. So it's the 110-meter hurdles, which is part of the year, right? So the year should mention the name as well. Obviously, I thought it was a good idea to update my my Neo4j browser earlier, which I probably shouldn't have done, which is causing some strange things here, but that's okay. You can tell that we can start querying it. The data set is there, right? There's some default queries that I can start running here, like for example here, what is related and how is it related, right? Which is basically going to tell me that there's athletes that have genders that represent countries, the exact data set that we were expecting. On my server here, I'm using the awesome APOX, Neo4j APOX. I don't know if you've seen these yet. The APOX are our awesome procedures, right? They are a way of running Java code and accessing Java code from Cipher, which you can just install on your Neo4j server. And this, I have done that here, so I can go call APOC meta graph, and hopefully that will actually give me the data model that I was trying to load earlier, right? So I've got my years, my city, my country, my athlete. There's something here that those are the medals, and it's not showing the medal yet, but that's fine. Right, so this is exactly what I was hoping for. This is exactly the data model that I was hoping for, and it seems to have been loaded completely correctly. So we can start taking a look at that. Right, so load was successful. Now what we can do is we can start querying it. Yippee, right? So I've written a bunch of queries to have some fun with the data. And again, you'll see some of those queries here in my editor. I've also put them on GitHub, so you can look at it and see if there's anything interesting there for you. Like for example, we can look for the number of sports per game. We can start querying the Olympic graph, and we can start looking for a certain discipline, right? Now let me show you this. This I thought was super interesting, right? So I've got those queries right here, right? So number of sports per game. What I'm doing here is I've got a match, right? I've got a year, right? An Olympic event, right? Which is hosting events in a discipline in a sport. And I'm going for the distinct games and sports, and then I'm going to returning the game and the count of the sports, right? So then I can, I can basically say, how many sports did we have per game, right? This is interesting, right? In 1896, we only had 9 different sports, right? Then it grew a lot, right? We had up 22 in 1920, which is the Antwerp Olympics, I believe, right? And then it grew, but in 2012 there were only 22 sports. Just one second. I needed to cough, I'm sorry. Right, so then we can start looking at different things, right? We can look at the medals table, right? The medals table for, let's make it 1920, right? The medals table for that year, right? You can see, the United States, and you'll see this all the time. There's quite a few people that had medals there. Then we can look at athletes with this I thought was interesting, and I actually had to think about this one for a bit. I wanted to figure out, which athletes had medals in games that were hosted in their home countries, right? Which is actually going to be, if you think about this a little bit, right? So it's actually looking at the loop here, right? So if I go epoch meta graph, right? There's a loop in here, as you can see, right? There's the year, the Olympic year, city, country, medal event year, right? And then there's an athlete. So I need to look at that loop, which is really easy to do in Cypher, right? So if I just use some of these identifiers, right? I've got year, event, medal, athlete, country, city, and then year again, right? So I'm looking at that pattern, that loop in the data set, right? And I'm trying to figure out, which years did we have most people that had sort of like a home advantage, right? So in Britain, there were quite a few medals at the London Games. Let's see here. Well, what else have we got? Oh, I just wanted to show you this one. This I thought was interesting. Like for example, this thing here. Oh no, that's a different one. Sorry, excuse me. I wanted to show you the sports per game, right? So I can do collect. That's what I wanted to do, right? Right. This is what I wanted to show you, right? This is the list of sports at every game, and what I didn't know, at least, is that tug of war was an Olympic sport, and from 1900 till 1920. I thought that was pretty interesting. Yeah. Let's look at some Olympians, right? So matching for an athlete, right? Looking at the number of medals that they had. And then, there's some very famous names here. Remember, this is until 2012, right? Michael Phelps only had 17 medals at the time, and as you know, that's changed in the meanwhile. But there's Latinina Larissa, right? So if I go freewheeling here a little bit and ask who she might be, right? So I go boom. And return A, right? And I can start exploring that, and damn it, those are the medals, right? And look at which sports that must have been in. That's in a team competition for something else, Let's see here, the vault, right? This, oh, here we are. This is the one that I was looking for, the artistic gymnasts, right? So this the discipline I have no idea why it's not showing up in the right color here. I'm sorry. And then you see that artistic gymnasts is actually part of the gymnastics this sports, right? Sorry, this was a bit messy. I hope you were bearing with me there. Let me just wrap this up. There were a couple of really interesting queries that I wanted to highlight, like for example this one. Olympians with medals in different sports. Right? This is interesting, right? I mean, if you look at the enormous amount of specialization that we see in the sports industry these days, it's pretty obvious. How is it possible that someone was doing fencing and shooting and fencing and aquatics and weightlifting and shooting and tennis and athletics? That would never be possible today, right? But yet again, that did happen. These guys were very much complete athletes, right? If you Google for this guy here, you'll very quickly see his name, Otto Hirschman, one of the few Olympians that actually had these multiple medals, and there's quite a bit of history here that's interesting to look up on. But the most recent Olympians, right? So you can actually explore that a little bit. The most recent Olympians that had medals in different sports. You can see them over here. It's actually in 1912, right? So in 1912, that's when the last time that someone had an Olympic model in 2 different sports. Lots of other stuff that you could do, like pathfinding operations. There's so many things that you could explore, right? Once you have the data in this format. I'm not going to go into all of that. You can query the Olympic graph yourself once you feel like you've got an appetite for it. The load script and the queries are all on GitHub, right? And we'll share those with you after this webinar. I'm sure there's other stuff that I've missed, and there's other stuff that you will find out that's much more interesting. But I'm hoping that you guys thought that this first attempt was a good introduction, and it shows you a little bit, how do you put that data set together, how do you import it, and how do you model it, and then how do you start querying it. Corey, I think we'll wrap up the presentation part of this webinar. If there's any questions, I am obviously very, very happy to answer those.
Perfect. Thank you so much for that presentation, Rik, and thank you everyone for joining us today. If you have any questions, you can go ahead and submit those in the questions box of your GoToWebinar control panel, and we'll start to take a few of those now. All right, Rik, I'll go ahead and start asking questions to you. The first question is about the population in the graph. It says, so the population includes only people who won a medal? So wondering if...
Yes.
All right.
It's just the medalists. I mean, and again, I didn't. This was just an exercise for for me to waste some time. So you can probably find more and in more interesting Olympic data sets, but this was only the medalists. Yes.
All right. Perfect. Then we have a few questions about the GitHub code and the text that was used for the creation of this data set. Will we go ahead and make that available post-webinar?
Yeah, totally. Go to my GitHub account.
Oh, you're a little quiet for me, but I think that you've answered that with a yes.
Oh, sorry. I think that was my mistake, Corey. Can you hear me now?
Oh, yes.
No. So if you look at this gist on GitHub, so gist.github.com/rvanbruggen, you will see the Olympics Olympic medalists gists there. One of them is a load script, and here at the bottom there are the queries.
Perfect. And we'll go ahead and make sure to send that out also in our follow-up email along with the slides and the recording of today's presentation. So either go ahead and find that just on GitHub yourself or know that it will be emailed to you. All right, some other questions. including people commending you for your great presentation, Rik.
Thank you so much.
It says, after loading the graph, how is it possible to modify the data?
Oh, well, I mean, with queries, right? So if I go here and I would say, oh, no, here, Rik, sorry. So if I don't know, I want to find a country with a name called Belgium. Oh, sorry. Right. So here and return C, right? This is how I find Belgium. Now I could basically say, okay, I don't want Belgium to be called Belgium. I would want it to, oh, sorry. I want c.name, set c.name equal to the majestic kingdom of Belgium. Right? I'm just making this up. And then you can say return C again. Right? So I mean, this is now the name, as you can tell, right? I've made this up on the fly, but now that particular node is not called Belgium anymore. It's called the majestic kingdom of Belgium. It's still connected to everything that was originally already connected to it, but we've modified the graph. So you can do that with Cypher, and I think maybe your webinar attendee may be asking for, how can I do that without writing Cypher code? In that case, you would either write an application on top of the graph, or you would use some standard tools that allow you to do this. I mean, there's some standard tools that allow you to very quickly edit the graph, whether it's a visualization tool or some other, fat client application. There's different ways of doing that.
All right, perfect. We'll take just a few more questions.
Yeah, sure.
So the next question is, let's see. Can you talk a little bit about lookup and reference data and how the graph model handles that?
Lookup and reference data. Well, so in my exercise here, I basically have multiple data sources, right, which I put together in this particular spreadsheet, right? And the spreadsheet actually has four different tabs that all correspond to the different CSV files. So I'm essentially importing data from different reference data sources already, right? Now I can full well imagine that, some of that reference data, I wouldn't control it. Something something else or someone else would be authoring or writing that reference data. In which case, you have the choice. Do you actually want to import that data into Neo4j and work with it there, or do you just want to have a pointer to it, right? And basically have Neo4j manage the links to that reference data, or do you just want to keep it completely separate and let everything come together in your application, in your software, right? I think that all those options are viable and are possible good solutions depending on your use case. But in this particular case, what I did was I brought everything together, right? And then I had multiple. I brought all of the reference data together, and I had multiple runs to connect all of that into the same graph database.
All right, great. We have a few questions here on loading data. Specifically, is there a tool that someone can use to import data? And then a second question from someone else that says, when loading big data, is it possible to load extremely large amounts of data? And if you could talk a little bit about the limitations there, that would be great.
Sure. Well, so loading data in a graph is something that I wear a lot of scars from. It's right, people are used to relational databases and just dumping stuff into it. And you have to understand that what you're doing when you're importing data into a graph is a very different type of operation, right? You don't have a schema that you're dumping stuff into. You're actually, your data is the schema. You have to do more work as you import data into the graph database. And this is not Neo4j specific. This is any graph database, right? So you have to do more work, and obviously that means that there's more possibilities for failure. There's more possibilities for problems, and you have to think it through. You have to understand what you're doing. Now, I believe Neo4j has gotten so much better at this. It's really, really quite easy to use now. The main tools that I use to import data are actually part of Cypher, right? It's the load CSV, right? So if you Cypher Neo4j load CSV, right? This is a developer guide of how to use this, right? And it takes you through the different steps that you have to go through in order to do a good import job. Load CSV is probably the most important tool for you to use. Having said that, and this relates to the second part of your questions, how do you do that at scale, right? How do you do that at really large scale? I would say the load CSV offers you a bunch of possibilities already, right? By basically batching up the import automatically, right? There's I don't know if it's a periodic commit. Yeah, you'll see that over here, right? Periodically committing, right? So as you may know, Neo4j is a transactional database. Transactions have more overhead, and therefore, if you atomically commit every single load operation, it's going to take a lot longer than if you batch them together and periodically commit those load operations, right? So that's one thing that you really want to take a good look at, is the batching of your import statements. When you get to, thousands or 10,000s or 100,000s, this will work fine, right? Even with millions, this will just work fine, unless you have like a very crappy computer, right? With very little memory. If you want to do it at real big scale, and I'm talking about millions and billions of rows that you need to import, then you really should be considering offline import, right? Import, and Neo4j offline import is also described on our website. It's basically a mechanism that allows you to do the entire import untransactionally or non-transactionally, right? So the entire import will either succeed or fail, right? And that means that while you're doing the import, you don't have to be committing transactions. You're just dumping data in there, and the speed would just be uncomparable, right? If you do things transactionally or non-transactionally, the speed is completely uncomparable, right? It's like seconds to minutes, that type of comparison, right? So at large scale, have a look at the offline import, right? Have a look at the batch importer, because it's going to be night and day. I'm hoping that kind of answers the question.
All right, perfect. We'll go ahead and just take a few more questions, but if you do have any that you'd really like to speak to us about, go ahead and send an email to webinar@neotechnology.com, and we'll make sure to answer that directly for you. All right, Rik.
Go for it.
Perfect. How do you determine when to use a rule-based versus a cost-based optimizer?
How do you determine it? You look at the query plans, right? So here, if I do, let's take a look at the query plan here, right? So I've got a query here which matches which looks at the count of the medals, right? Here, if I preface this with profile, right? Then what you will see is not only will it actually show you the result, right, which is identical to what I did before, right? But there's a little tab extra here called the query plan, right? That query plan tells you what the database has done to get you your results. This is every step that has been done. It scanned for nodes by label. It did a projection, another projection. It started filtering. It added distinct operator. This is what it's been doing, right? It also shows you here at the bottom which version of Cypher it's using, which planner it's been using, and the runtime it's been using, right? So if this runs fine, right? If this meets your needs, meets your expectations, then I would say use the default. Don't do anything here, right? If, however, you think that there's some benefit to be had by using the rule-based planner, then all you need to do is prefix this thing here, right? And you can prefix it with profile as well, right? And see what happens, right? And guess what? This is probably going to be a little bit slower, right? It's actually interesting, right? Because it comes up with a different plan, right? So this one starts with node by label. This one at the bottom starts with node by label scan. Those are different operations, and don't ask me what the detail of this is, right? It shows you here, this is the rule-based planner, right? But yeah, that's how you work with this. By the way, there's another keyword that might be useful here, which is explain, right? Instead of doing profile, you do explain, which is a lot faster, right? Because explain does not run the query. Profile gives you the profile and runs the query. Explain only explains the query. It doesn't run it, right? But yeah, that's how you work with this. You start with the default, which is going to be cost-based, and we really believe that cost-based planning is the way to go. But if it gives you any issues, like it did in my import example, then use that prefix and switch planners.
All right. Perfect. I'll go ahead and ask you our last question. Can you mention pointers to APOC and what they can be used for?
Oh man, APOC! I'm so in love with APOC. It's APOC is APOC is interesting. You'll find a lot of stuff about this online and on the documentation side. This is actually, and I actually very recently I interviewed one of the authors of APOC, Stefan Plantikov. If you want to know a little bit more about it, look at this podcast episode, because Stefan was one of the authors of the APOC mechanism. What is it? Well, it's a way to mix Cypher, the declarative query language of Neo4j, which people love to use, with compiled Java code, right? Neo4j has always had different ways of interacting with it, right? From embedded Java to query language to Gremlin there's always been multiple ways to interact with Neo4j, right? We believe that for the vast majority of our users, Cypher is the way to go, the declarative query language where the user declares what he wants and the database is actually tasked with finding the data. That's how we think databases are going to work in the 21st century, right? We've got a lot of proof for that. However, there's always going to be a need for dropping down to, lower to the metal, closer to the metal, to APIs, to software that will run more efficiently, because it doesn't have that declarative approach. It actually, imperatively knows what needs to be done. Like, for example, in a Java procedure, right? APOCs allow you to write Java code that you deploy to the Neo4j server. It's as simple as dropping it into the, let me just go here to my Olympics data set, and this is my Neo4j browser, Neo4j folder, right? And I'm using the 3.10 milestone 6 release. You will find there's a plugins directory there, and in that plugins directory, I dropped this jar file, apoc, and then version number .jar, right? And this allows me to access a wealth of different procedures, stored procedures that can automate certain tasks that maybe Cypher isn't doing yet, or isn't doing very efficiently, or whatever it is that you're doing here. There's a lot of them here, and some really useful things, which I've been using ever since it came out. This has been available since Neo4j 3.0, which we launched in April 2016, and the response to it has been overwhelming. It's crazy, right? So you've got so many of them. If you're going to do some advanced Neo4j work, please go here. Please look at this stuff, because there's a wealth of information there. Problems that you may be facing in Cypher today are easily resolved with a stored procedure. And if the stored procedure isn't shared yet, or isn't available yet from this library, then you know what? Contribute. Contribute something back. Write something yourself, and share it with the community. This is the way to do it.
All right.
Hoping that answers the question.
Definitely. Thank you so much, Rik, for that presentation and for taking all of those questions. And thank you, everyone, for joining us today and for submitting so many excellent questions. Again, if you didn't have yours answered and you would really love to hear from us, just go ahead and send an email to webinar@neotechnology.com, and we are more than happy to get back to you.